In the previous video, I have explained atomic structure part 1. Today I am going to introduce atomic structure part 2. Whenever I prepare any video, my priority is to give benefits both juniors as well as seniors. That means atomic structure chapter starts from standard 6 and it continues till standard 12. So my priority is to give topics related with 6, 7, 8, 9, 10, 11. Atomic structure part 1 video that I have already given. In that part there is a basic. You can say it is for standard 6, 7, 8, 9 students. For ICSE it starts from standard 6 only, and for CBSE it starts from standard 9 only. But the today video that I am going to give, this is for senior students. In this video I will explain dot structure in detail, both for organic compound as well as inorganic compounds. Second thing, I will explain hybridization, very important points. That is the backbone of chemical bonding, BIHAR theory, to give shape of organic compounds or inorganic compounds or physical compounds. So first I am going to introduce dot structure. I have already explained, whenever we are going to make dot structure, we need valence electron. And the purpose is to fulfill duplet or octet configuration. That means whenever we are going to arrange valence electron to share or to show the sharing of electron between two or more than two atoms, our priority is that central atom or the other atom must fulfill its octet or duplet. But there are some exceptions also. We need to focus that also. So first I am going to explain dot structure. Here I have already explained dot structure of hydrogen, nitrogen, oxygen, methane, then ammonia, then water. I have already explained. So today I am going to explain CCl4, carbon tetrachloride, then C2H2 ethyne, C2H6 ethane, C2H4 ethene, C6H6 benzene, then NO3 minus nitrate ion radicals also, CO32 minus, that is for carbonate, PO4 3 minus, that is phosphate, then halo group, then aldehyde group, then alcohol group, then carboxylic group. So these are the compounds whose dot structure we need to solve. Here I have made common dot structure for physical as well as organic compounds. So for CCl4, whenever we are going to make bond of CCl4, we have to select which one is central metal or central element. Here central element is carbon, or 4 Cl atoms are there. One thing I want to remind you that dot structure we use here, the dot structure that I am going to use, this is for covalent compound as well as coordinate compound. Because for electrovalent compound there is transfer of electron takes place, and there are limited compounds that I have already explained in my previous video. So this is based on covalent and coordinate compound, and I have explained wherever covalent or coordinate compound we need non-metals. When there is a metals and non-metals, So if the bond is formed between metals and non-metals, we can say it is definitely electrolyte or ionic, because ionic transfer, there should be one donor and one acceptor. But when there is a bond between atoms or group of atoms in a covalent compound, sharing of electron takes place, and this sharing we need electron deficient element, so they all are non-metals. So here I am using carbon and chlorine. I will take, first we need to take valence electron. I have already explained that for suppose Cl, so how many electron is shared between carbon and Cl, that is important. So chlorine atomic number is 17, it is 287. Sorry, to fulfill octet it needs only 1. So out of 7, 1 will be between carbon and Cl and the remaining 6 will be outside. Because I will explain, as many electrons are required to fulfill octet, that electrons must be kept between two atoms. As chlorine has 7 electrons, out of 7, 1 is involved between carbon and Cl and remaining 6 outside. So here we have filled, carbon has 4 electron, valence electron. So as equal participation, this is important, that sharing always takes place equally. Covalent sharing takes place equally between two atoms. If one atom is giving its 1 electron, other will also give 1 electron. It can never give 2 electrons. There is an equal contribution between the two combining atoms. So here this way duplet octet of this way octet of chlorine has been fulfilled. I am showing only 1 because it will only 1, and the octet of carbon has been. So we can say that there are 4 single covalent bond develops between carbon and Cl. This is a covalent bond between carbon and Cl. Then this is organic compound C2H2, C2H6, C2H4. Suppose you want to draw dot structure of C2H2. So 2 carbon and 2 hydrogen. Mind it, if there are 6 hydrogen, then in case of organic compounds, 3 hydrogen will go with each carbon. 4 hydrogen, 2 hydrogen will go along with each carbon. 2 hydrogen, 1 hydrogen will go with each carbon. So I have drawn, and I have already explained that hydrogen has no option, it has only 1 electron. This carbon has 4 valence electron, so 1 will be here and the remaining 3 will be here. This carbon has also remaining 3 will be here, 1 will be here. So duplet of hydrogen has been fulfilled and octet of carbon. For 2 electron single bond, for 6 electron triple bond. Like this we can draw ethine. For ethane, each carbon will carry 3 hydrogen. And first we fill electron of hydrogen, mind it. It will be easy to explain if we draw right electron of hydrogen, then it will become easy to decide how many electron of carbon will go this side. So 4, so here also 1. Because equal sharing is going on. Duplet of hydrogen and octet of carbon. Octet of carbon. So here single bond formation takes place between carbon and. Here one thing I want to remind that if there is a single bond present in a compound, we will use another name for this. This is called sigma bond. What is sigma bond? What is pi bond? I will explain later on. But if group of, suppose here in ethine, here triple bond is there and here single bond. So all single bond considered as sigma bond. Sigma bond always exists singly. pairing of sigma bond is not possible. And the remaining 2 bond is the pi bond. So you can say that in ethyne there are 3 sigma bond and there are 2 pi bond. Pi bond is a weak bond. What is difference between sigma bond and pi bond? I will explain when I will start orbitals and the shape and size of the orbitals. Similarly, suppose we have to draw the structure of C2H4. Each carbon will carry 2 hydrogen. I am using different dot for carbon and hydrogen. For carbon, so it will be easy to identify which dot belongs to which elements. So this is double bond. In this way, this is ethene. Now, for the radicals, how will we draw dot structure of radicals? One by one, I will explain. Nitrate ion. One more compound is important, that is ammonium ion, NH4 plus. So, when in a given radicals negative charge is present, then negative charge always will go with most electronegative element. What I want to say, that in the periodic table the most electronegative element is fluorine, then oxygen, then nitrogen, then chlorine. Here negative charge present over the entire group, entire unit, but this negative charge will go along with oxygen because oxygen is more electronegative than nitrogen. So central is nitrogen and 3 oxygens are there. So out of 1 oxygen we will put negative charge. Negative means gain of electron. I have explained in the chapter atomic structure. So in place of 6 it has 7 electron. So this 7 electron is between 2 atoms and the remaining 6 outside. This nitrogen has 5 electrons. So here will be 1 and the remaining 2 will be here. When we are going to draw dot structure of radicals, first we will draw one anion, then center and then the rest. Why? Because I will explain. See, if you see the diagram, then you find that this nitrogen has already 6 electrons. 5 electron belongs to valence electron of nitrogen and 1 electron has been given by negatively charged oxygen. So it needs only 2 electrons with to fulfill its octet configuration. That's why this nitrogen either share with this oxygen or with this oxygen. So suppose we can use this oxygen is using its 2 electron. Now octet of nitrogen has completed. Very important. So this oxygen needs 2 electrons, so it will form here coordinate bond with the nitrogen. So we can say that N equal sharing single bond, equal sharing double bond, sharing between 2 atoms but the electron is given by nitrogen, so it is a coordinate bond. This way we can draw dot structure of nitrate ion. For carbonate, there are 2 negative charge. So each oxygen out of 3, 2 oxygen will develop minus charge because oxygen is more electronegative than carbon. So it has 7 electrons. Unpaired electron always will present between 2 carbon atoms. Or I have already explained the number of electrons required to fulfill octet. Suppose 7 is here, so out of 7, 1 is required, so 1 is in between 2 atoms and the remaining is outside. So here also 1, remaining 6 outside. This carbon has 4 electrons, so here 1, remaining 2. So octet of this oxygen has completed. Octet of this oxygen has completed, but carbon needs 2 more electrons to fulfill its octet. So equal CISCE takes place between carbon and oxygen. So here oxygen will put its 2 electrons inside and remaining outside. So here all the bonds are covalent bond. There is no any coordinate bond. So whenever we are going to draw dot structure of radicals, we have to be careful that whether coordinate bond formation takes place or not. Next is phosphate group. Phosphate ion, 4 oxygen. Out of 4 oxygen, 3 oxygen will carry minus charge. So 1 electron of each oxygen, remaining 6 outside. Phosphorus has 5 valence electrons, 1 will be here. It has 5 valence electrons, 2 will be here. Now, phosphorus octet has been completed. Octet of oxygen ion has been completed, and phosphorus octet has also been completed without using this oxygen electron. So, this oxygen electron will use its all valence electron outside the atom, not between oxygen and phosphorus. And here a coordinate bond formation takes place between oxygen and phosphorus. So we can say it is single, single, single. Here minus charge is this, and here coordinate. This is the structure of phosphate ion. Ammonium ion. So I have explained that in a negative radicals having negative sign, negative charge will go with oxygen. Similarly, if we are using a radicals having positive charge like NH4 plus, here positive charge always go along with hydrogen, because nitrogen is a electronegative and electronegative element. So hydrogen will feel its electron here, here, here. This hydrogen has no electron. Nitrogen 5 electron, remaining 2 here. So we can say this, as this positive charge present with any carbon, any hydrogen, so we can write like this. Coordinate one. Next, this organic compound chloroethane. This is chloroethane. So 2 carbon. Each carbon, first carbon has 3 hydrogen. Second carbon has 2 hydrogen. First we will fill electron of hydrogen. Then we will fill electron of carbon. Then we fill electron of chlorine. This way. This way. So here each carbon and hydrogen single bond, carbon carbon single bond, single bond. This is single bond. This way we can form chloroethane diagram. Next is a aldehyde group, alcohol group and carboxyl group. One example I have taken. The rest part will continue like this. So next is we have to discuss for aldehyde group. So aldehyde has this structure. And 3 hydrogen, each carbon has 3 hydrogen and then CHO. So first we will fill this. This carbon has 4 electron. This carbon also has 4 electron. Here 2. Because here no elements are there, so here we will fill to check that whether this bond is fulfilled or not. This oxygen needs 2 electrons for sharing, so 2 electrons here and remaining 6, 4 outside. Duplet, 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 octet, octet, duplet. So here single, 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 double, single. This is the structure of aldehyde group. Here carbon. So you can say 1, 2, 3, 4, 5, 6 sigma bonds are there and 1 pi bond. Wherever 2 bonds are there, you must, it is important that one must be single sigma bond. Without sigma bond, bond formation not possible, compound cannot exist. And if you have additional bond, if the compound has additional bond, it must be pi bond. Next is the alcohol group. Methyl group always be same. Methyl group is common. So we can easily draw methyl group. So this is the methanol. Suppose there is ethanol. So one CH2 is added, C and H above below. So it is easy to draw CH2 like this. CH2 here. So if the number of carbon will increase, we simply add that group. Then next last is ethanoic acid. I have already explained this ethyl group. So same ethanoic acid, 3 hydrogen. If you compare this and this, then you find that it has only 1 oxygen, it has 2 oxygen. How will we identify distinguish aldehyde with carboxylic acid? Carboxylic acid has 2 oxygen, whereas aldehyde has only 1 oxygen. So here 2 oxygens are there. So 1 oxygen will be here, 1 oxygen will be here. 3 hydrogen you first fill. Then carbon. This carbon, this oxygen, this oxygen, duplet, duplet, octet, 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 octet. So we can write C, single bond C, single bond. So we have seen in all these compounds, octet configuration and duplet configuration has been fulfilled. But there are some exceptional compound also where octet and fulfill is not possible. For example, BeCl2, beryllium dichloride. In beryllium dichloride, octet will never fulfill. So here beryllium has only Cl, 2 bond formation takes place. Such type of compounds are called electron deficient compound. It is called electron deficient compound. Or there is another word that is very popular, Lewis acid. When equilibrium part 2 I will teach, on that time I will explain what is Lewis acid, Lewis base. But here BeCl2 or all electron deficient compounds are taken in the category of Lewis acid. In the same way, BeH2, we draw dot structure of BeH2. Then BH3, it is also electron deficient compound. BH3, boron has 3 electron only. Hydrogen has sharing of 3 electron takes place. So it is also electron deficient compound. This. So we can say that Lewis acids are BH3, B2S6, BH2. Now SFPCl5, phosphorus pentachloride. As you have already guessed, HCl has 1 electron, a single bond, so 5 bond means 10 electron. It is superoctet, electron excess compound. Superoctet. It has electron more than octet. Outside electron I am not showing. I think you must have got it that. But you have to, in the exam you have to use, you cannot avoid it. I am not using. So here 5 bond formation takes place between phosphorus and chlorine. Then SF6, 6 bond. Same way 6 bond formation takes place between sulfur and fluorine. So these are superoctet compounds, electron excess compound, PCl5 and SF6. So whenever we are going to draw dot structure, this dot structure is very important, because on the basis of dot structure, later on I will teach you how to find shape of the given compound, how to find hybridization. So this bond is important. Unless we know bond, we cannot guess shape or hybridization of a given compound. So now I am going to introduce a new concept, that is BSEPR theory, that was given by Sidney and Powell. Lewis dot failed to explain shape of the compound. That what is the shape of ammonia molecule? What is the shape of carbonate groups? So BSEPR theory gives idea how to form shape of a compound, and I am going to introduce that now. So I have explained dot structure of 3 types of compound. First is compounds having octet configuration, second electron deficient compound, and third electron excess compound, that is superoctet. Now I am going to explain BSEPR theory. BSEPR theory. This theory is suitable for shape of the compound. Sidgwick and Powell explained. Lewis failed to explain shape of the compound, and this theory is applicable for those compounds where bond pair as well as lone pairs are present. Suppose I am taking one example, CH4. In CH4 all the bonds are bond pair. So this law, according to this theory, here bond pair, bond pair, bond pair, bond pair. So repulsion between 2 bond pair is minimum. According to this theory, lone pair repulsion is maximum, then lone pair bond pair repulsion, and this is maximum than bond pair repulsion. So here the least repulsion of the compound, that's why its shape is tetrahedral. But if you take the structure of oxygen, this is the structure of oxygen. This is lone pair, this is lone pair, this is bond pair, this is also bond pair. So here lone pair repulsion, lone pair bond pair repulsion, and bond pair repulsion. Due to maximum lone pair repulsion, maximum distortion of shape of water molecule takes place. So you can say that here the bond is coming very closer because bond pair repulsion is less. So because electron pair occupy large space to minimize repulsion. Lone pair occupy large distance to minimize repulsion. So we can say that oxygen molecule has bent shape. If you see the structure of ammonia, in ammonia there is only one lone pair and 3 bond pair. So this category repulsion is absent in ammonia. In ammonia, repulsion between lone pair bond pair is present and repulsion between bond pair is present. So distortion in ammonia is less than distortion in methane. So like this, it had a pyramidal shape. This is pyramidal shape. So if you compare the structure of methane, water and ammonia, then you find that in methane there is a repulsion of bond pair, no bond pair lone pair, no lone pair repulsion, minimum distortion. If you compare the bond angle of methane, then it is 109.28 minutes. This is about 105 and this is about 107. So you can say that bond angle of methane is greater than bond angle of ammonia and bond angle of ammonia is greater than bond angle of water molecule. So this is all due to distortion of the shape. Water has maximum repulsion due to lone pair repulsion. So maximum distortion takes place in the compound and shape has changed. So more example I want to take XeCl4. It has 8 electrons. Out of 8 electrons, 4 are involved in the bonding. And the remaining 4 electrons present as a lone pair. I am using electron, only 1 electron. This electron I am not using. So you can say that lone pair, bond pair. So due to lone pair repulsion, this compound has octahedral structure. Square planar structure. The bond pair occupy this is the structure of XeCl4. So in this way we can say that shape of any compound depends upon valence of the electron. This valence electrons can be 2 types, either in the form of lone pair or in the form of bond pair. And repulsion between lone pair is maximum than repulsion between lone pair, bond pair and bond pair. In the next video, I will explain orbital concept. What is s orbital, what is p orbital, what is d orbital, what is f orbitals, and how these orbitals are used for hybridization, and then we will combine dot structure, BSEPR theory and hybridization together to form another property that is going to be very important for us. Thank you.